In a triangle, two sides that measure 6 centimeters and 10 centimeters form an angle that measures 80 degrees. Find to the nearest degree the measure of the smallest angle in this triangle. So, first thing you want to do with a problem like this is draw a picture. Even though you really can't draw the whole triangle yet because you don't know exactly what it looks like, take your best shot at drawing what you think this triangle might look like. So we want to draw an 80-degree angle, so it's almost 90 degrees. It's almost going to be straight up. And we want the bottom to be longer, right? Because we want this to be about 10. We want this to be about 6. And I'm just kind of eyeballing this. And then this here is going to be the third side. Let me see if I can draw this somewhat straight. Okay, so there's our third side. And we don't know how long that is yet. And it says that it forms an angle, so the angle between the 6 and the 10 is 80 degrees. So this was the angle that we were trying to make 80 degrees. So now you're probably wondering, how close is this to scale? If this is a good sketch, which we don't know for sure that it is yet, then we suspect that the smallest angle will be this angle because it's opposite the smallest side. But there is still the possibility that if the sketch isn't very good, maybe this side that's unknown is actually the smallest side. Although if you want to kind of make a prediction in your head as to whether that is likely to be true, we know this is an 80-degree angle. So it's probably impossible, right, that either of these other two angles, it's impossible that both of the other two angles could be bigger than 80, right? So that 80 was the smallest one. So what I'm getting at is that this side can't be the shortest side. But even if you couldn't conclude that right off the bat, that shouldn't slow you down from continuing this problem. So let's label this a bit. So I'm going to call this angle, so let's just say A, B, C. So I'll use capital letters to denote the angles, and I'll use lowercase letters to denote the sides. So lowercase c is this unknown side, B is 10, that's the known side, and A is 6. That's the other known side. So if we ultimately want to know the smallest angle, and we suspect it's going to be angle A, then perhaps we could use the law of sines if we knew the opposite side. So we don't have enough information. In order to use law of sines, you need 3 out of 4 in terms of sides and angles, and we don't have enough. So if we have 2 sides and 1 angle, we can use the law of cosines, and that will allow us to find side C. And then once we have side C, we can use the law of sines to find angle A. So let's walk through that. And I'm going to write down the formula for the law of cosines as a starting point. So c squared, and this is lowercase c, so we're looking for side C, that's what we want to know, is equal to a squared plus b squared. So it starts off looking kind of like the Pythagorean theorem, but then it has this little adjustment, minus 2 times ab cosine of angle C. And that now is capital C because it's angle C. So everything on the right side of this is known, and we can actually calculate side C. So let's do that. So I'm going to keep this as c squared for the time being. A is 6, so 6 squared is 36. And I'm going to show some of the work, but I'm going to do a little bit in my head. I'll make sure I say out loud everything that I'm not writing. Plus b squared, b is 10, so that's plus 100. 10 squared is 100. Minus 2 times 6 times 10 times cosine of 80 degrees. Alright, so c squared equals 136 minus 2 times 6 times 10 is 120 times cosine of 80. And if you put that into your calculator, cos 80 times 120, and then you carry out this subtraction, you will find out that c squared equals 115.16, and so c is then the square root of that, which is 10.73. So this confirms our suspicion that side C was not the shortest side. So this is a good thing. We should feel like we're on the right track here. And now that we have another side, in fact the side that corresponds to the one angle that we have, we can use this side in combination with this angle, and then A being a known side with this unknown angle A. And now we can use the law of sines to find out what angle A is. So remember, the law of sines in general, so I gave you the law of cosines here. So if you don't have this in your notes, you don't remember this, you need to go back and look at it again. This is the law of cosines. This is the general form of it. The law of sines is sine of angle A divided by side A is equal to sine of angle B divided by side B equals sine of angle C divided by side C. And you can use these in any combination, so you don't have to use all three. You can say just A and B, or just A and C, or B and C, whatever's convenient. So in our case, we're going to use C and A. So we don't have to worry about using B in this case. And now I'm going to make this substitution. I'm going to go directly and start substituting in as though this was sine of angle A over side A equals sine of angle C over side C. So sine of angle A is what we don't know, so sine of A over side A, which is 6, equals sine of angle C, which we do know, it's 80 degrees, over 10.73. And that number has been rounded off. And now, if you cross multiply 6 times sine 80, 6 times sine 80, and sine A times 10.73, and then divide both sides by 10.73 to get sine A by itself. So sine A equals 6 sine 80 divided by 10.73, and that turns out to equal 0.551, and I'm running out of room, so I'm going to jump over here. So in your calculator, you need to find A, you need to take the inverse sine. So inverse sine of 0.551, and that will give you the measure of angle A. And angle A turns out to be 33.4 degrees, or if you want to round that off, we could say A is approximately equal to 33 degrees, and we'll have given it to the nearest degree, which is how they wanted it. A is about 33 degrees. And just as a sense check, if A is 33 degrees and C is 80, and the total sum of the internal angles of a triangle needs to add up to be 180, then you can deduce that angle B must be 67, which seems about right because it's a little less than angle C, and side B is a little less than side C. So its corresponding angle should be a little less. And that leaves A as being the shortest angle. Sorry, the smallest angle.